Welcome back for section 4-5. So this is kind of the build-up of where everything we've been doing so far of what it's been progressing towards. So the graphing, the factoring, all of this was coming together so we can eventually solve quadratic equations, okay? So solving quadratic equations. Now what that means is, spoiler alert, when I get down to here, being able to say, all right, what x value solve that? When I plug in certain x values, which ones will give me 0? Okay, now, the way that we eventually get there is called the zero product property. Okay, the zero product property, and again, I know you saw this back in Expo, so this should ideally be a review for you. But the zero product property essentially says, in order for two things to multiply to 0, one of them has to be 0, okay? Because if I list things that multiply to 0, so 0 times 5, negative 1 times 0, 2/3 times 0. The thing that they all have in common is at least one of those pieces must be 0. If I multiply two non-zero numbers, well, I'm not going to get 0 then, right? We're going to use that property right here. So what the zero product property says is either x plus 5 has to be 0, meaning x equals negative 5, or x minus 7 has to be 0. So x would have to be 7. Okay, so again, I know you saw this back as 9th graders, but again, just a review to make sure you remember why we're doing what we're doing. Zero product property lets us solve these things by saying, hey, when we find this, at least one of those parentheses has to be 0. Same thing right here. So 2x minus 3 has to be 0. Add the 3 over, divide by 2. So here, x is 3/2. Or x would be negative 4, oh, sorry, wrote that backwards, negative 9/4. And the reason that this helps us is because when we're looking at things like this, we can factor these quadratics and then apply the zero product property on them, right? So again, we just did all that time remembering how to factor. So here, x minus 2, x minus 3, because I need two things that multiply to 6, add to negative 5. And what that's telling me is my two solutions. So here, x would have to be 2 for that to be 0. And for that to be 0, x would have to be 3. So here I get my two solutions, okay, by using this factoring so I can apply the zero product property. And the cool thing is you can check your work. You can check to make sure that you just did this right. So for example, if I want to convince myself 2 actually is an answer, again, let's just check our work. So here, 4 minus 10 plus 6, that does equal 0. What about the 3? 9 minus 15 plus 6, that does equal 0. So again, the neat thing is with any equation is you can actually go back and check, hey, did the two answers I found, did they actually solve what I started with? So don't ever be afraid to go back and check to make sure that what you've done has worked, okay? So again, first step is always factoring. Now this one, hopefully you recall, because it was the last lesson that we did, difference of squares, okay? Easiest one, but also the easiest to forget. Difference of squares always has that plus minus relationship. The x squared comes from x, the 100 comes from 10. And so of course this one right here means x would have to be negative 10 to make that parenthesis 0, And that parenthesis, x would have to be 10 to make that 0. And of course, you could always plug both of those back in to check your work. So negative 10 squared, 100 minus 100, checks out, that does equal 0. And you can even check your other one too. 10 squared minus 100. 100 minus 100 does equal 0. So both of your answers check out when you put them back into the original equation, okay? So just always, again, be aware, you should go back and check your answers. Before you hand in your test to me, you should know if you have those equations right or wrong. All right, so now, of course, to use the zero product property, well, it has the word 0 in it for a reason. The only way that this works is if all of it is actually set equal to 0. So I have to subtract that 14 over first, and now I can apply my zero product property, okay? So let's take a look at this. So that 3x squared means I have 3x and x. 14 means I have 2 and 7. So I'm going to get that. Again, when you're factoring, always make sure. So here is 7x minus 6x does give me the positive 1x that I want. Okay? So again, you can always also go back and FOIL what you did to make sure you actually have the proper factored form. And now zero product property, of course, this one is easy, right? You guys can really quickly see that an x of 2 makes that thing 0, okay? When it gets to the more complex ones like this, I do recommend show your work. Show that you're trying to get that to equal 0. So you have to subtract the 7 over and divide by 3. Okay? So again, do take that extra time for those more complex ones to make sure that you're doing it right, okay? Because I'd hate to see you lose easy points because you're trying to do too much mental math without showing your work. And then, of course, I'm not going to keep showing you this, but of course, keep in mind that you could plug those back in and check in the original equation that those work. Again, I'm not going to keep doing that for every single problem because you get really bored with me, but just make sure you know that that is an option. Here again, emphasis on the zero product property. I need to subtract that 15 off, and now I can factor this. 2x and x make x squared. So now negative 15 has some options, okay? So 3 and 5 or 1 and 15. All right, so here, if I put 5 here and a negative 3 here, I get negative 3x and 10x to get me that 7x, okay? So here's my proper factoring. Then, of course, this one right here, that one's going to be really easy for you to identify, okay? The other one, when it's a little bit more complicated, that is where I would like to show that you're actually trying to find when does this thing equal 0. So to find that, I have to add 3 and divide by 2. All right. And last example. So here, now this one, what I notice, 4x squared and 9. I have two perfect squares, okay? So here, I'm just going to go out on a limb and try my first thought of these. Now, how do I get a negative in the middle? two negatives on the inside because that multiplies to be positive. So that's how I multiply to be positive 9, add to get a negative. Now again, this isn't always going to work, but it's a nice starting point just to check. And now let's see. So here, negative x, negative, or negative 6x and negative 6x, that did actually give me the negative 12x. Now this one, spoiler alert for you, this comes really special, or gets really special in section 6. This is called a perfect square trinomial, when you get two of exactly the same thing. Okay? So, when I have two of exactly the same thing, I really only have to solve that once, right? Because both pieces are going to give me the same thing. And there you have it. All right. So now I do want to take a moment to have a conversation with you about why are these things important, okay? So what are we doing graphically? Because I said graphing was also leading up to this. Well, when I look at x squared minus 3x minus 4, that factors to x minus 4, x plus 1. So that gives me solutions of 4 and negative 1 when I solve that via factoring, okay? Now, what if I were to graph this thing, okay? So put a y there and graph it. I want you to notice something. Look, there I have a point when x is 4 and x equals negative 1. So really what you're finding when you're solving, those are the same thing as the x-intercepts of the graph. And that should be coming back to the idea that we did back in chapter 2 when we introduced functions. I showed with linear functions that this was the case. I showed you with absolute value functions this was the case. So now this is the third time you're seeing this, okay? That you're getting solutions that are the same as the y-intercepts if you graphed it, okay? And this isn't going to be the last time either. There's chapter 5, this comes into play. Chapter 6, this will come back. So this is a reoccurring theme that when you're solving equations, what you're finding are the x-intercepts of those equations, okay? So I want to show you one more example of that, okay? So the function 0 or y equals negative 0.03x squared plus 16x models the path of a kicked soccer ball. The height is y, the distance is x, and the units are meters. We want to know how far does the soccer ball travel? All right, so when we're looking this up, so here we need our graphing calculator, and this time, instead of factoring it, because that thing honestly looks like a headache to try to factor, we are going to use our graphing calculator. So go to y equals, and you can type that in, okay? Negative 0.03x squared plus 1.6y. And what we just learned is if I'm trying to solve this and figure out when is this equal to 0, well, that's the same thing as the x-intercepts. Now, when I graph it, you can see right here, it started at 0, and then it's going up, right? But this doesn't quite look like a parabola, okay? That's because I'm not getting a good picture of this graph. Notice those numbers were not exactly nice numbers. So I'm going to readjust my screen a little bit, okay? So I'm going to zoom out so I can get a better picture of this quadratic, okay? So now I'm seeing a little bit more of the parabola, except I'm not seeing the other x-intercept yet, okay? My graph isn't going big enough. So I'm just going to go and I'm going to adjust my window a little bit so I can go a little bit further in the x direction. I want to get a good image of this graph. And there we go. Okay, much better visual of this graph. Okay, and again, I did this by adjusting my zooms and adjusting my window. Okay, and again, most things I give you, if I ever expect you to graph it, will be nice, but this is a good skill to have, that you can adjust the window on here to see things. So when it asks, when is it going to hit the ground again? That's asking for that x-intercept right there, okay? Is asking, when is my function going to be 0? Now this is kind of a spoiler alert for chapter 5, because you're going to see this skill. So right now, consider this just an introduction. You don't have to have this mastered yet, okay? So just watch me through this. If it doesn't quite make full sense yet, that is totally okay, because you're going to see these things again in chapter 5. So based on my graph, I want to calculate, when is my graph going to be 0, okay? That finds the x-intercept for me, okay? So I'm going to scroll over. It's asking me to be left of my point. So here I'm left of my point. Then I'm going to go and be to the right of my point. Then here, this is the 0 of my function, okay? So there is my solution. When will it be back on the ground? How long does it take to get back to the ground? 53.3 repeating, okay? So that's how far my soccer ball went, okay? 53.3 repeating. We're talking about meters. So that's how far this thing went. What about how high? Okay, well, how high? It got up to here. Okay, that's its highest point, is up there. So I can do a calculation, and to find how high, now I'm finding the maximum. So again, it wants me to be to the left of this maximum. So I'm going to scroll to the left. Scroll to the right. So its maximum height, again, y is tracking my height in this case. Its maximum height is at 21.3 repeating meters. Okay. So, and again, if you don't have those mastered yet, that is totally fine. I just really quickly showed you how the calculator can do this for you, just so you can kind of get intrigued on what it's capable of. But really, this is going to be mastered when we get into chapter 5, okay? However, there is one thing I want you to be able to do for me with this information. So the domain. This is a real world situation, right? So real world situations, the domain won't be as simple as all real numbers, right? Because for example, negative numbers don't make sense. So for the domain, the x values that are being used, does it make sense to you that only these x values are being used from 0 up to that 53.3 that we found? Because real world, that's when the soccer ball hit the ground again. It's not going to keep going. It doesn't make sense to keep tracking beyond that. So my domain would be that. My range, well again, how high or low does this thing go? My range only makes sense to go from 0 up to that maximum point, right? It doesn't make sense to track negative numbers because my soccer ball can't go under the ground, okay? So domain and range, when we're talking about real world situations, I do want to make sure you understand that real world can kind of limit some of the things we're talking about in terms of realistic values, okay? Oh, so lots of good stuff in there, okay? So again, really quick, write your summary for me. Again, with the focus of the summary being on the factoring piece, okay, this graphing piece, again, I just wanted to expose you to, but don't worry, you don't have to have it mastered until next chapter. So write your summary on the factoring piece, how are you feeling about that, and then come back ready to do your practice work.